Hi everyone, we are Group 94. Today we are going to talk about our final project EDFS. So our main teammates includes Junfeng Liu and Haochen Yang. So before we talk about the code implementation, let's firstly talk about our design logic and general thoughts for this project. So as we all know, EDFS actually has two main parts. One is name node and the other is data node. So in our project, we actually use Firebase to emulate both name node and data node. And we will use a name node to store the structure of the file system and also the location of the files and their partitions. And we will use the data node to emulate to store the actual data in different partitions. And for our project, we mainly break the task into following three tasks. So for the task 1, we will build EDFS and the system commands. For task 2, we will implement the partition-based map and reduce functionalities. And for task 3, we build a Jupyter interface to support EDFS command, and also we implement a navigation command CD to allow users to interactively navigate through the EDFS, exploring its directory structure and fields. And for the task assignment, for Junfeng Liu, I'm actually in charge of the task 1 and task 3.2. And for Haochen Yang, he is actually in charge of the task 2 and the task 3.1. So now let's get into our code. So here is actually our Jupyter interface for the EDFS. And here is the actual code and the APIs that we implemented. So now let's firstly talk about task 1, the EDFS system and their corresponding system commands. So let's firstly import the EDFS from EDFS. And then let's initialize an EDFS object. And after initialize the EDFS object, we will see on the Firebase, we actually already have the data node and the name node. So that's actually the functionality for the initialization. And the code basically looks the following. We will assign the path for the name node and data node and check whether this node exists or not on the Firebase. If it's not, we will just create one. And this is for the name node, this is for the data node. That's actually the code. And now let's make a directory. So firstly, we make a user, and then we make a user Junfeng and the user Haochen. And let's see. For the Firebase, we can see we actually successfully created those directory users Haochen Junfeng. And the logic of the code are basically the following. So make a directory code. So for this code, we have argument called directory. Firstly, we will check whether this directory is a valid directory or not. If it's not valid or empty, we will just pop out a message called usage make a directory name. Otherwise, we will try two possibilities. One is for the relative path and one is for the absolute path. And for each of these possibilities, we will firstly clean the path and then check whether the parent directory exists or not. If it exists, we will check whether this file, this directory already exists or not. If it exists, we just pop file exists. Otherwise, we will create a directory. And we will use a for loop to firstly check the relative path and then the absolute path. If either one has been successfully checked or created, we will directly return and ignore the following possibilities. If both possibility doesn't exist, we will just print an error message called no such file or directory, which is mainly for the parent directory. And now let's take a look for the ls command. So after recreating the user Junfeng, user Hao Chen, let's check what do we have under the directory user. So we can see we actually have the Hao Chen and Junfeng, so that's correct. And for the coding implementation, this one is actually pretty straightforward. So we can see, basically, we will check whether the directory is empty or like it is current directory. If it is, we will just like accumulate this path, like store this path. Otherwise, we will try two possibilities. We will try whether we will have a relative path or we have an absolute path. If that's the case, we will store the path with these two possibilities. Then, after checking this block, which is like what kind of possibility we have, we will check this possibility one by one. So for the cases and possibility we just have, we will firstly check whether we will firstly request the Firebase to see to grab this URL, and then we check whether this one exists or not. If we find the return value is not empty, we will just like list all the key values for that, which is like the key values under that dictionary, which are the corresponding directories under that path. And then let's try CD functionalities. For CD, let's go to user Hao Chen and let's print where we at. So we can see CD and PWD are actually together. So after we move to the user Hao Chen, we just print current directory. We see we are under user Hao Chen. And the implementation of that is basically here. So for CD, we will have argument called path. And we will check whether path is empty or is like tailed. If that's the case, we'll directly return to our root path, which is empty. And then we will check the case one, whether the path is relative. It's a relative path. And if that is the case, for the relative path, firstly we will consider we will check whether it's a relative path. If it's not relative path, we will check whether it is a absolute path. And for both these situations, we will see whether we have a request. If request, we mean it actually exists. So we will execute that possibilities. And now let's go back. CD dot dot, CD dot dot, and PWD. And the current directory. We can see it's already empty, which means the root directory. And then we list current directory. So we can see we are in the root. So we have a user in this directory. And then let's try another command called put. This function will actually put CSV files and their data to a specific path using 3 numbers of the partitions. After we execute that, we can see on the database. You can see on the database. So on the database, we will see we just push the DS salary and use the default method to store it. So we can see on the name node, we will have partition 1 with corresponding data node path, partition 0, partition 1, partition 2 with their corresponding data node paths. And also on the data node, we will have for each corresponding path, we will have a partition that stores actual data. Just like that. And let's push another data set. This is salary saver. So let's check the database. So we can see, oh, we have that salary saver and also salary saver. And see all use both default method to store. And these are actually the partition, the data stored in the partition. That's basically the logic. And we also support, for the put method, we also support using users to indicate some methods. And currently we support to store data by using the job title. So we can see job title. And we can see we store the salary saver by job title. So what it looks like. So we can see here for Hao Chen salary saver, we have job title method to store it, which will have the partitions, 3 partitions with corresponding data node partition paths. And for the data node, we have for the corresponding paths, we actually store them by using the title. And for under each title, we will have the corresponding data. Yeah, that's basically how it works. And for the put functionality, let's just look about the code logic. So for the put, we will firstly get the data here. And also we will check the method. And for the method, for different method, we will like do the partition for both the name node and also the data node. And finally, after we getting the structure, this part is actually stores the actual data into the data node. And this function, let's try next this command. It's called get partition location. So for the user Hao Chen DS salary dataset, the corresponding partition locations are the following. You can see the data node user Hao Chen, a default method, and also the partition. Those are the random case. And this is for another data set. Let's see. So we can see the return. Yeah. So, and another function is raise a partition, which is like raise a data set with a partition 1. And we can return the value. Let's look at that. So these are the values. And the code implementation for that is for get partition location, we just directly check the name node and get the name node for that data set and get the corresponding data node path under that name node. And for read partition functionality, the implementation logic are basically we will check the name node and get the path, and also we will get the path for the specific partition, and we will go to the data node to get the actual data. Yeah, that's basically for test 1. Now I think Hao Chen will talk about we also have another function called cat. So cat will actually print print that data set in a panda format for that specific data set. And we can also remove that data set, remove the DS salary. Yeah, remove successfully. We can also remove the whole thing, but we will not try because we will, for the test 2, we will use partition-based map and reduce to reach, to search and analyze the data. And Haochen will talk about this part.
Hi everyone, this is Haochen, and I'm going to talk about the task 2. So like for task 2, we've built a partition-based map and reducement. So basically, like let's say it's high level of this concept is that like we have stored like plenty of partition data like in the database because the data size is very large. And therefore we want to like process the whole data. So we want to use this method to reduce the time that we cost, time and the space that we cost. So it basically means that we process each partition separately, and then we store the result from it. And then we combine in the reduce step, we just like combine this result like that we came from the every partition and then combine them together to get the final result. So that is basically like the high level mean of the partition-based map and reduce. And therefore, like we've got like several functions to do this work. Like we have get average salary for each jobs, and then we get like get job titles like based on the salary range. And then the third one is to get the average salary like in different location. Also, the last one would be like we count the ratio of the like we will count the remote ratio for the different jobs. And basically like this four functions have the similar like process because we as I said before, like we just do the process of the each partition in the first step, and then we store the result for them, and then we in the reduce step we combine those partitions result and to get the final result. So let's talk about like the first function, like get average salary. So it's basically just as the same that you understand in the function name, that it's just get average salary, but its input has the file path and also the title. So the title means that which job you want to get the average salary. And if you don't have the title, or print get the title with all, so you will print like the function will process all the like jobs with its average salary. And as you can see, like they do the map partition first, like they process each partition and then do the map reduce. I combine those data together and get the final result. And let's try like use the interface in the Jupyter notebook. So it's this one. Oh, I forgot to put something on there. Yeah. And as you can see, like for this one, we have the all parameter for the title, and then we calculate the average salary for all the jobs. It's really large. And then we do the data scientist. We want to figure out the data science average salary, and it's relatively small, as you can see there. And basically, that's what it does in the get average salary function. And then we talk about the second function. It's get job titles in salary range. So basically, it's what it's doing is to get the job titles and count the number of jobs, count how many people like for this job, like based on in the salary range. Like as you can see, like the input is still the file path and also the left range and right range. So therefore, we can like shuffle the data with only show the data that has whose salary are in this range. And also we process each time we process the data, the partition data, and then store it and do it in the final results and to combine them. And it's just like use the data framework like pandas to get the range from that and count the number of the job titles. And each time we return the job counters, like the jobs and its occurrence, and then we store them. And then we, in the final results, we just like put this data and combine them together, so that the occurrence with different partition would like combine together to add them together. And then let's talk about the code there. So it's we want to care about like is there any like job titles jobs that's larger than 30,000 and less than 60,000. And as you can see, like there are like plenty of them, and there are like sorting by like descending order. And it's like it seems like data scientist has the greatest numbers around this in this range. And then let's talk about like the third. It's just get the average salary based on different location. So it's similar, like as I said before, that they have the similar process, but this one is similar to the first one, but it's based on the different location. So we just like calculate all the numbers that has the same location, put them together, and then return and each time we just store the sum of the salaries and its locations. And then in the reduce parts, we just put them together, add them together. And let's see, run the code. Oh, this one. And you can see like it's also descending order. You can see like in the RU state, RU has the best average salary. Yeah, maybe you should go that after you graduate. Yeah. That's a suggestion. So let's talk about the count remote ratio, the last function. So it's just count the remote ratio for like different jobs, like for all the data, and a similar process. But each time, like we store the occurrence for like because there are three kind of like remote states, like no remote, half remote, or fully remote. So therefore, we store like each total occurrence for each each remote state, and then in the final results, we just put them together and calculate the ratio. So do it. And as you can see, like it shows the jobs titles and 3 states, and for each jobs, it's just gives 3 ratio states, as you can see. So that will be the count remote ratio function, and that will be all for the text 2. And then let's talk about like task 3. Like for the navigation, we got for the interface, like we got like because we are a team of 2, so we just get the Jupyter Notebook to be the interface. You can just do the same as we do, and you will get the result. And then like for the navigation, user navigation system, like we got the CD function as talked before. We use CD to like get into some or relative path or absolute path, and then we could show our when we show our path, we will get what we are. And that's it. I think that's it for it's pretty long, so that's it. Thank you guys.
Thank you for listening. Bye.
Bye.